Here's an example of a proof where you're going from a false conclusion to a false, or from a false premise to a false conclusion. Let's find our standard form. We have it is false that, then we have some are not. Be careful of those are and are nots, and making sure that you're identifying a term complement or a some are not. Then we have therefore, it is false that, and then we have all are. Then we look at the terms. Well, advocates of equal pay for equal work and advocates of equal pay for equal work are identical. I'm just going to use an A to represent those. But then feminists and non-feminists, look, they've given you the term complement. So we'll just use F and non-F. Our standard form would then be, it is false that some F are not A, and you would have to include this on a test. Therefore, it is false that all A are non-F. The first line of our proof would be, again, to repeat the premise. It is false that some F are not A, given or assumed true. And then we go to the square to start off. So that's where we've got our information. What's the only thing we know? Well, we know that it is false that some F are not A, some are not indicates that that's an O statement. So we've got a false O statement. That means that A is true by the contradictory relationship, I is true because of subalternation from A, and we could say that E is false either by subalternation or by the contradictory relationship. Now, in this case, we want to keep it false. So we don't want to go anywhere on the square or use anything on the square that's true. So now we need to choose between using the E statement, the false E statement, or the false O statement. Here it's a little bit clearer as to why you shouldn't use the O statement. And that's because you're already there. You're already using the O statement, so there's no reason to stay there. It becomes clear that E is the only choice to make. So we keep the false because we're not getting rid of it. It's still false here on the square. And we simply change the standard form around the terms. So it becomes an E statement, no R. But F and A stay the same. And how did I get, again, not around the square, but how did I get from here to here, showing my work as I go, each line of my proof? Well, the relationship between O and E on the square is subalternation. So that's the reason I will give. Carrying that false down, I see that I need to make this no and all. I need this F to be a non-F, and I need this A and this F to switch places. So let's do the simplest thing first. Let's just perform conversion. So that'll just switch the places of the subject and predicate terms. But that's not enough. No A or F, that only gets us into position to use obversion, because once that F is here, we know that we can use it to achieve this conclusion in the end. So if I then use obversion, it changes the no to all. It changes the, replaces the predicate term only with its term complement. So F to non-F, and it leaves the subject term alone. Now, do these look the same? Does my work look the same as the conclusion? Yes, it is false that all A are non-F, absolutely. And I'll give you another little hint. If you were to imagine that this answer was removed, and we'll just call this answer partial answer number 1, and I'll work the other one in green, and you just started again from the second line of it is false that no F or A with subalternation, there's at least one other way to work this proof. And that is that oftentimes, in fact, just about every time, that you can use conversion and then obversion, you could have used obversion then contraposition. It just depends on your preference and I guess what you would call style of doing proofs. So if we were to work it that way, we would see, actually, I'll just work it in the same color ink and then I'll show you what I mean. In other words, starting from it is false that no F or A, ignoring this conversion and obversion as the first way to do it, and continuing on here, you might want to do obversion first. That might look more obvious to you. So it becomes all F are non-A. But then you think, oh my gosh, okay, well, I have a non-A, I needed a non-F, what do I do? But if you use contraposition, remember contraposition leaves the all R alone. It leaves the standard form alone, but it takes the subject and predicate terms, switches their places and replaces both of them with their term complements. So this non-A comes over here and becomes A, and this F comes over here and becomes non-F. Using contraposition. So this is a second way to work this particular proof. You will also see that there are examples in your textbook where the person working the proof has chosen to use conversion, obversion, or contraposition first, and then go to the square. That is also perfectly fine. Again, I'm only trying to teach you a consistent strategy wherein you start off your proof, go immediately to the square, use the square for what it can give you, and then don't worry about having to go back to the square afterwards. As long as you are careful and you're sure that your proof is accurate, you can use these tools in any order that you see fit or that actually gets you to the proof. Again, these are just two different ways to do it. You could have done it some other way where you went to the square of opposition last. It's really up to you. It just has to be accurate.